Yo, last video I learnt C++ and OpenGL and managed to create a barely functioning framework along with this small demo. And in this video I'm going to scrap that framework and make a new and improved one, along with another cool project at the end. Let's get it. The first thing I did was to begin planning, as I wanted this version of the framework to be organised, so I set my project up with CMake. I know this sounds like an obvious thing to do, but in my previous video, I literally made my own makefile, so it's an improvement. According to a Cherno video I watched, I was told to keep the framework or engine separate from any game I'd make with it. The engine should only have the functions and tools required to make a game. In my case, I made the game framework a separate library that can be added to any game I make with it. Once I had the basic structure sorted, I copied some of the boilerplate code from the GLFW documentation and I had a window up. In the last video I made, I used SDL to create the window, load images and handle surfaces. However, I've realised I don't actually need it, as I was doing all the rendering through OpenGL anyway, and I can use other libraries for loading images, sounds and fonts. I started following the Cherno's OpenGL tutorial, as it helped me to write some better quality code. Progress was slow, but I started rendering triangles, then quads, eventually loading PNG files and displaying them. Here is a texture class I created while following the tutorial. And here is some of the code for loading an image into an OpenGL texture. The STB image library is used to load the PNG file into main memory. Then the OpenGL texture is created and its parameters are set. Finally, the image data is passed into the GPU and deleted from main memory. I also installed IMGUI, which is a GUI system that should hopefully make testing and debugging easier when it comes to making games. I got my framework working on the web with CMake. I made a bash script to easily compile the Windows and web builds. I also had to change parts of my code to handle being compiled within Scripton. Like last time, I just had to add these lines of code when I wanted to use the GL library for the web build, instead of the GLFLW library for the Windows build. Now time for some event handling. I made a simple function to get key inputs, and now I can control this blue square with my arrow keys. I also made the program run at 60 FPS on Windows and used vsync on the web build to reduce CPU usage. I then added mouse inputs. Oh, not that one. There we go. I created a timer and delay class to hopefully make coding up time and animation related features with the framework easier. They are pretty simple classes, so I decided to leave them in the header file. Once created, they hold a current time and an end time. The delay object also holds a function to execute once the timer has run out. Every frame, the timer or delay object can be updated. I can get the amount of time passed in seconds or as a percentage by using these functions. Here is a small demo I made using the timer object. The square changes colour whenever a button is pressed. This obviously could have been made without the timer object, but it does reduce the amount of lines of code I have to write and makes it easier to read. Next, I added instancing. According to Learn OpenGL, instancing is a technique where we draw many equal mesh data objects at once with a single render call, saving us all the CPU to GPU communications each time we need to render an object. And an instance buffer is just a buffer that holds data per instance. For example, I can have mesh data for a square and an instance buffer for some square attributes. So when I send a draw call to the GPU with this mesh data and the instance buffer, the squares will be drawn with different sizes, colors, and positions while having the same mesh data. In my implementation, instance buffers are just like normal buffers, as in vertex buffers, but when I add the vertex array attributes, I have to specify that the current attribute is instanced. I just had to modify my add buffer code to check if the current buffer was going to be an instance buffer. If that was the case, I would call GL vertex attrib divisor and set the divisor to 1. This makes the attribute update per instance rather than once per vertex. I made a function called create model matrix that takes in a position, size, and rotation, then generates a model matrix for me to use. A model matrix is essentially a matrix that determines the position of an object within a scene. After that, I turned my attention to the entity component system, and I can't lie, I straight up just copied the code from my previous video. An ECS, aka an entity component system, is made up of entities which can represent blocks, players, or enemies in a game. Each entity can have multiple components. There may be a component for position, health, hitboxes, etc. The last thing in the ECS are the systems. They can loop through entities and make changes to them. For example, a health regeneration system might loop through all the entities with a health component and add one to the health. I made a drawing system that utilized instancing. It's similar to the health regeneration system example. However, this time it loops through entities with a texture, position, and size component, then draws them to the screen. It was very quick to make this because of all the classes I had created, and soon I could create multiple entities and draw them to the screen. After quickly making this random function, we now have many rotating squares on the screen. But plain red squares are boring, so I quickly put together this texture of like 4 blocks. In order to display the textures instead of the red squares, I had to create another instance buffer that held the texture clip of a current entity. I then created a function called surfClipVector that takes in the surface clip position, its size, and the texture size as inputs. It then generates normalized coordinates for selected texture, which can be used in the drawing system shader. Turns out, I had a lot of errors in my code. I should have done more testing. Anyway, I got it working eventually. A feature that was currently missing was rendering straight to textures, but this is where frame buffers came in. This meant I could render the game display onto a texture and render the texture onto the screen with some fancy effects. I did this in my last video. In order to make this work, I created a frame buffer class. The class also allowed me to make fill functions for the textures. This took me so long. Anyway, here are some of the fancy effects I can use. I also made my drawing system work with multiple texture atlases at once. This required yet another instance buffer that contained a number that referenced the current texture of the entity that was being drawn. What should have been a 30-minute job took like half a day to get working because I was using glvertexAttrib pointer instead of glvertexAttrib I pointer. This led to OpenGL assuming the unsigned integer was a float and messing up all my calculations. Anyway, it was working and that was all that mattered. In the fragment shader, I had to make this long if-elif statement because when compiling the web version, GLSES kept giving me an error about using non-constants to index an array. Anyway, after that I turned my attention to handling collisions. I created a new component called physics layer, as this could be used to filter collisions between different groups of entities. I created a collision system that uses the physics layer and the rect component manager. I tested the system with my mouse cursor by just deleting any tiles I hovered over. It was at this point that I decided to add source control to my project. I created a GitHub repo and added my code to it. Source control is very important as it means I don't lose any progress if my work was to not save. I can also roll back to earlier versions of my code, allowing for quicker testing. I probably should have done this a bit earlier, but better late than never. Text rendering was the next thing I dealt with. I used FreeType to help me with this. It is a library that helps rasterize.ttf, TrueType font files, and provides useful information about each character, like its size and offset. I made a series of functions that help to load and render fonts. This layer of abstraction reduces the amount of code I actually have to write when making games with this framework. I use this article in the FreeType documentation to help me make this feature. However, that only got me part of the way there, as the article used a separate texture for each character. This would be very slow and would also lead to a separate draw call for each character displayed. So I found a video by Cakes that helped me to render all the characters to a single texture. Then from there, I was able to create a function that used instancing to draw each character, similar to how the drawing system worked. After a lot of debugging and silly errors, and some help from ChatGPT, I got some text rendering. I decided to use OpenAL to handle the audio in my framework. It was the first library I found, and it said it was cross-platform, so I couldn't really ask for anything else. I found the tutorial for OpenAL by Code Tech and Tutorials. I didn't really use it, but it did reference this article, which was my main source of information when using this library. I'll link both sources in the description. The library is kind of like OpenGL. I mean, it's literally called OpenAL. Like in OpenGL, I still have to create a context and make buffers. They're both cross-platform, and they are both state-based APIs, so it did really feel like OpenGL. Most of the development process sounded like this. but I eventually got it sounding alright. The only problem I have now is that it takes like 10 times longer to start up and stop the program, ever since I added OpenAL. I'm not sure if this is normal, but I guess I'll just have to deal with it. With the main systems of the game framework in place, I thought it would be a good idea, just like in my last video, to create a small demo to test it. This time I decided to remake this, one of my oldest Pygame projects called Rocket Run. It was basically an awful Flappy Bird clone, but I was proud of it at the time. I first started with the art. I found a palette on low spec and created some simple sprites for the pipes and player. I soon got a window up and running and displayed the tile map using the framework with a few lines of code. Creating this small remake helped me improve the framework as I was using it to make an actual project, and wow, there are a lot of improvements still needed. Anyway, I got these pipes eventually moving across the screen and made their vertical positions change randomly. Next, I added the player, which is controlled by holding the spacebar down. I made a quick start and end screen that also displayed your high score. It doesn't write your high score to a file, so if you close the game, you will lose your high score. I don't think that matters anyway, because I was focused on making the web build. I added some nice post-processing, along with some more polish, an animated background, a game over animation, some rocket particles, and some sound effects. And here is the final result. Next time I work on this framework, I'll probably want to create some sort of scene editor, as that would speed up game development by a lot. There are also some smaller changes and bug fixes that need to be made, but I'm happy with the progress I've made so far. Making this project has drastically improved my C++ skills, but I'm still far from writing good C++ code. I'll get there eventually, I hope. If you made it this far, I want to thank you for watching. Making these videos takes a while, so yeah, it means a lot. Anyway, peace.